Colin, you ready for the big game this weekend?
I'm jacked for the state championship game this weekend, but right now I'm failing AP Calculus in Mr. Breeze's class, and I have this huge integral test coming up, and I know absolutely nothing about it.
Man, the pressure's really on. But can't you get some help from someone in class?
Like who?
Like that nerd that sits next to you.
Who?
There's that little nerd, I don't know his name.
Oh yeah, we'll get him.
Yeah?
Hey man, what's up? Who are you? I'm in your math tutor. Who are you again? I'm your math tutor. Oh, you're the little dweeb that sits next to me. AP Calc, right? Yeah. Alright, so you're gonna help me pass this test so I can play the state game or what?
Yeah, let's do it. I'm really excited to hang with you here. So we can go learn lunch.
I guess as long as nobody's around.
Yeah.
Alright, let's do this real quick.
Really easy. So, do you understand derivatives at all?
A little bit. I'm a little shaky on them.
Okay, well that's fine, because derivatives are really easy. All you do is take your exponent, bring it down, multiply it by the coefficient, and take your exponent minus 1.
What? Yeah, dude. No, because I don't know what you said, dude. I don't know.
Okay, well, I thought this might be a problem, so I think I know someone that might be able to help you, Colin.
Okay.
Power, you add 1, you bring it under. You got your power, you add 1, you bring it under. One more time. Your power, you add 1, you bring it under.
Colin, so, for example, if you wanted to take the integral of this, you would add 1 to your exponent, and then you would bring this down, which would give you over 3, and then your integral of this would be 6x cubed.
Oh, I get it. That's easy enough.
Yeah. Think you can pass the big test?
Hopefully.
Okay. So, Colin, how you feeling about the big game?
Yeah, bud. Not much. Feeling pretty good, but I'm a little worried about finding the area under a curve. Think you could possibly help me out with that?
Yeah, just pass me a ball and I can kind of explain it to you. So, you know when you find the area under a curve, you need a function, an upper bound, a lower bound, and an x and y axis. So kind of like basketball, you can think of the path of the ball as your function. You can think of your hoop as the y-axis, your ground is the x-axis, and you are the upper bound. That sound good, man?
Yeah, that sounds great. Why don't I stick to basketball and you stick to teaching me? Sounds good.
So, let's say the path of this ball could be represented by the function 3x squared. And your lower bound, which is the hoop in this case, will be at 0. And your upper bound is going to be at 6 because you're 6 feet away. If you wanted to find the area underneath this curve with respect to the x-axis, your lower bound is 0, and your upper bound is 6, and your function is 3x squared. So, all you would have to do to find the area is take the integral, which remember, you add 1 to your exponent and bring it down below, which would give you x cubed, and then you plug in your upper bound minus your lower bound, and whatever number you get is the area underneath your curve.
Nice. Right now, but I was wondering if you could teach me how to find the area between two curves.
Well, Colin, I'm glad you asked. Let's say Liz swinging is our lower function, and the path of this ball is our upper function. Okay, so if I throw this ball, so that's a good real-life demonstration. Let's go see what it looks like on paper. Okay, so let's say, Colin, that this function right here is represented by the equation negative 3x squared. Okay, and this bottom function is represented by the equation 3x squared. If you wanted to find the area between these two curves, you would simply take your lower bound, which is 0, and your upper bound, which is 6, and you're always going to take your top function minus your bottom function. So you're going to have negative 3x squared minus 3x squared. And then from here, you're just doing the same integration that we've been doing. So we add 1 to each exponent, and then bring it down and divide by that. So you'd have negative x cubed minus x cubed from 0 to 6, And remember, you're taking it, you get these bounds because you're taking it with respect to the x-axis, and that will give you the area between these two curves. So from here, you're just going to plug in your 6 cubed minus your 6 cubed, and then you're just going to minus your 0 cubed minus 0 cubed. And your answer is going to be negative 432.
That makes sense.
So, do you think you can pass the big test coming up?
I believe I can.
Okay.